Hi guys, so in this video here we're going to be looking at the theorem of Pythagoras, right? I'm sure we know Pythagoras. We've been doing it since grade 10, right? So we're going to be looking at the theorem of Pythagoras, right? But what I need you to note just before we start is I hope you have done all the other theorems, because the Euclidean of grade 12 needs you to know the following theorems. Firstly, you need to do all 7 theorems of grade 11, right? I have the link to those theorems in this video. Check the description. Secondly, you need to have done theorem 1, which talks about the proportionality, right? The triangular proportionality, or line is parallel to one side of the triangle and its converse, right? Its converse, right? And then number 3, you should have done theorem 2, right? Which talks about the equiangular triangles, which are said to be similar, right? Equiangular triangles which are similar, and its converse. It also has its converse, right? And then number 4, you should have done the midpoint theorem, right? And it also has its converse, right? So it's converse. And then number 5, you should have done this one now, which is the Pythagoras theorem. So if you really want to master Euclidean geometry of grade 12, do these, right? Do all of these. Go through all the theorems, know them, understand them. You don't have to cram them. Just understand them, know what they mean, and then after you've known all these theorems that I've just indicated here, then try your understanding by doing more and more examples, right? To just make sure that you are able to solve as many problems as possible. Anyways, let's continue. But if you really want the videos for all these topics that I just mentioned are in the description of this video here, so you are covered. Let's now solve this last one. This one, it normally appears at the last question of your grade 12 paper 2, the Theorem of Pythagoras, and not everyone gets it right. So I hope you guys will get it right. So the Theorem of Pythagoras, what we are normally given, please check just at the bottom of this video. Just here you'll see on your screen, I've written the reason of this theorem, right? The Theorem of Pythagoras, the reason that you always have to use if you are to prove or you are solving a problem that talks about the Theorem of Pythagoras. You can just state that reason. Just see the screen, it's written there, and I wouldn't remove it. It will appear throughout this video. Anyways, so what we are given, we are given a diagram, right, which has angle A1, let me just say plus, angle A1 plus angle A2. This is just a statement that, or whatever that you're given. I'm just going to draw it, and then you're given that AD is perpendicular to BC. So the diagram that I'm talking about is this one here. It looks something like this, right? And then this would be let me just state it as C, just so that I'm able to adhere to this. So it's just going to be A, B, and C at the top, right? And then we have from vertex going here, obviously it's going to be 90 degrees here and here, and then this would be 90, the bigger one. So let's name this one D, and this is D2, this is D1, right? Say we are having this triangle, and we are told that angle A1 and A2, so this is angle A1 and this is angle A2, right? They add up to 180 degrees. So let me just for the purpose of what I've written down, I'm just going to write A1 and 2 here. right? So we are having this triangle here, and what we are to do, or what we are required to prove, is that the triangle of ABC, which is the bigger triangle, is similar, let me write it properly, is similar to the triangle of DBA. It's also similar to the triangle of DAC. So we are comparing, or the similarity of all three triangles that you can see in this specific shape here, right? There's three triangles. I hope you can see that. This is number one, this is number two, and number three is the bigger one, right? It's number three, right? Let me erase this. So yeah, we are comparing the similarities of these three triangles. So the first step is, let's start off by comparing two triangles, right? So we're going to compare two triangles and compare the other two, then it will conclude that all three are similar, right? That's how we're going to go about this. So let's look at this one in triangle ABC, the bigger one, and the smaller one, which is triangle DBA, right? So let's compare these ones using congruency. Remember that. So we compare using congruency, or let me say, we will just compare, finalizing the similarities of these. Obviously, we'll be checking the angles and the sides if the sides are there, but most importantly here, we'll be looking at the angles because that's what we have, which is mostly similar, right? If you check, angle A is equals to angle D1, right, which is equals to 90 degrees. So this entire angle A, this one here, it's 90 degrees, right, which is equals to D1, which is 90 degrees too, right? So you can just say given because it's what we were given. And then angle B is equals to angle B, right? So this one here is common to both triangles, right? Hence, we're going to say it's equal. So it's a common angle, right? And then angle C is equals to angle A1, right? Angle C, which is this one here, is equals to this angle A1 here, right? So we've proven three angles now, so which means these two triangles are similar, right? The reason for this one, you can just say it's a third angle of the triangle. So you've proven three angles, right? So once you've proven these three angles, then you can conclude and say triangle ABC is similar to triangle DBA, right? You can just state angle, 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 right? So you've concluded that these two triangles are similar. So once you've done these two, right? Once you've done these two, we're going to do another two, right? We can compare this ABC with this one here now, with this one here, this triangle here that I'm trying to indicate, right, with this pen. So yeah, that's what we're going to do now. So we've compared the bigger one with the smaller one. That's at the bottom. Now we're going to compare the bigger one with the other triangle that is at the top, right? Erase this. Erase this. So you remove this, and then now we are going to compare these two triangles. Just erase this so that everything is neat. So now we're going to compare triangle ABC with triangle DAC, right, which is this one here, right? So what can you compare between these two triangles, right? The bigger one has angle A, right, angle A, and it's equals to this angle D2. That's what we can say. Reason is given. We're given this. And another thing is angle C, which is this one here, is equals to angle C. So it's a common angle, right? It's a common angle. And angle B is equals to angle A2. So this is the third angle, third angle of the triangle. So you've proven 3 angles. That concludes that triangle ABC is similar to triangle DAC. So I'm assuming you guys are enjoying this, right? What we can take is this now. It's this now. Now that you've proven that these are similar, just gonna write it down here. So check. We've just proven previously, the previous step, we've proven that triangle ABC is similar to triangle DBA, right? That's the first thing we proved. And now we just proved that triangle ABC is similar to triangle DAC, right? So if we've proven these two, that triangle ABC is similar to triangle DBA, and triangle ABC is similar to triangle DAC. Therefore, these two are also similar. These two are similar, right? It confirms that. This is the common triangle we're using here, right? It's equal to this one, it's equal to this one. So meaning that these two are also similar. That's the conclusion that you get here, right? So if these two are similar, which means everything is similar, right? It confirms that triangle DBA is similar to triangle DAC. So once these two are similar, therefore everything is similar. Therefore, triangle ABC is similar to triangle DBA is similar to triangle DAC. I hope you guys understood this. If you didn't understand, please let me know in the comment section below, because this is very much important. You just need to understand it. You don't need to memorize anything. You just need to understand that the whole purpose of the Theorem of Pythagoras is to compare 3 triangles, the similarity of these 3 triangles, right? The bigger triangle with the small triangle, the bigger triangle with another small triangle, and all 3, right? Just concluding with all 3. Right? That's the whole purpose of the Theorem of Pythagoras. So once you've proven that, you will be fine in terms of solving the problem, because the problems will need you to know that. It will need you to know that these 3 triangles are similar to each other, right? Because now when you start finding the corollaries of these, you are using this similarity thing here. I'm just going to show you how we get the corollaries. I hope I'm pronouncing it correctly. Corollaries, right? The corollaries of these triangles from this similarity equation. So we normally find it like this, which is very important, by the way. You need to know the corollaries. Not necessarily know them as know them, because alphabets can come differently. You know, we won't always write ABC or ADB, whatever. You just need to understand on how to develop your corollaries so that you're able to manipulate some questions that you'd be asked in an exam, right? So once you understand this Theorem of Pythagoras, then the last question of your Euclidean geometry in your paper 2 is going to be simpler. It's always in paper 2, the last question. So anyways, let me show you this. So I'm just going to write this on top of here. So I'm going to say triangle ABC is similar to triangle DBA is similar to triangle DAC, right? So we're going to develop corollaries. Oh gosh, why is this name hard to pronounce? Corollaries, right? We're going to develop corollaries from these similar triangles. So this is what we're going to do. We're going to say AB, this AB here, I'm literally going to write it AB, right, over this DB, right, this DB, so it's over DB. DB is equals to, I'm going to write down this now. Let me erase here and erase here. So I'm going to write BC, right, So I'm going to write BC. That's why it's critical for you to write them in proper order so that you do what I'm doing. Is equals to, or I mean is divided by BA, right? And then you write your BA, right? Why is it important for you to write them properly? So that you can develop your corollaries, right? So here, you just cross multiply. You see there's AP here, there's AP here. When you cross multiply them, you have AP squared. AP squared is equals to DB multiplied by BC. So this is the first corollaries, corollary, whatever it is that you pronounce it. I hope you guys know how to pronounce this thing. It's actually spelled like this, corollaries. So I don't know why I'm struggling to pronounce it correctly. So we have developed one of them, right? Let's develop another, right? Using the similarities. So we've developed one. Now let's develop another. You need to know this just by understanding, not by cramming, because a lot of people just try to cram these things and you tend to forget. So let's develop the second one using the very same similar triangles. So we're going to say BC, which is this one here. I'm going to write it down, BC, right? And then we divide it with, now I'm looking at this AP and this one here, right? But it's up to you on which one you want to use. You can use the first and the second and the third, right? So now I'm just looking at these two here, right, to develop the second one, right? So hence I said BC, right? So it's going to be BC as I've written over AC, right? Which is this AC here, right? Fine. Done that. So let me remove this. Is equal to AC, right? Is equals to AC. Remember that your AC is this one here in your AP. Is equals to AC, which means you have to do the same thing here, or on the other one. You have to find. Yeah, you see what you do on this side, you also do on this side. So I said AC here, I jumped the middle letter, and then here I also jumped the middle letter and I said DC, right, over DC. See? So once you do this, you must be able to have like letters that multiply each other such that they give you a squared, right? They are similar or they are the same. So you can see here we have AC squared, which is equal to, so you cross multiply, so meaning this or multiply this. So it's going to be BC multiplied by DC, right? So yeah, this is the second corollaries, right? So the third one now, there are three actually. Hence I say you'll be given maybe a different shape that has different alphabets. So you can't just cram these alphabets here and say, oh, I'm just going to cram what you've written here and I'm going to develop the corollaries using this. No, you'll be given different letters. So now it will be a challenge. Just need to understand this. So the third one, right? The third one, we're going to look at triangle DBA with triangle DAC, right? I'm going to look at this, right? So to develop the third one, we're going to say DB, which is this portion here, will be divided with DA, not the political party. So it's going to be DB over DA is equals to, and then we're going to say DA, which is this one here, so we're going to skip a letter, so it's DA all over what? We do the same thing here, over DC, right? DC, the whole point is we have DA, so that when we cross multiply, DA squared is equals to DB multiplied by DC, right? So you leave it like this. So this is your third corollary. So now you have three corollaries. You are fine. You'll be able to solve any problem that has to do with Pythagoras in the exam question, right? So you shouldn't struggle. If you struggle, you go back to this video. You try and get your understanding on the theorem of Pythagoras, right? So there are three corollaries. I'm going to write them down. The first one is AB squared is equals to BC multiplied by BD. The second one is AC squared is equals to BC multiplied by DC. The third one is DA squared is equals to DB multiplied by DC. So that's how we go about solving the theorem of Pythagoras, right? If you have any questions regarding this theorem or you have suggestions, please let me know in the comment section below. Otherwise, thank you so much for watching.
Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.